Hi, I'm Steve Gompertz of QRx Partners, and welcome to this week's Quality Heretic. I think a lot of you probably know my business partner, Mark Swanson. Mark and I have been in business together for 6 years, and we've taught together for like 10 years. So we've been around each other a long time. And I suppose it would be easy to think that Mark and I must agree on everything with that much time together. The reality is, no, we don't always. And this week is going to be one of those examples. I'm sure Mark will have some great things to add to the conversation in the comments section. And so, what we're going to be talking about is these concepts of root cause and apparent cause. Um, this is an interesting one for Mark and I because Mark doesn't like me using the term root cause. He doesn't like anybody using the term root cause. And his reasoning for that is because that term doesn't actually appear in the standards, either 9001, 9000, or 1345. It does appear in passing in 1345, but not really as part of any of the requirements. You'll always see the word cause, right, without root in front of it, right? But we all have heard of root cause analysis and root cause thinking. So despite the fact that it's not actually specified that way in the standards, I still think it's really important to think about that. And that's what I want to talk about today, because when we're doing investigations of nonconformances or corrective action or preventative action work, right, you need to really figure out that sequence of events, right? You don't want to get hung up on the symptoms or the apparent cause, right? The most obvious thing. And so let's start with an example. I like plumbing examples because usually everybody gets that, right? We all have plumbing that we have access to. So this is actually the handheld shower head in my bathroom. And if you can see in the picture, there's some leakage here, right? It's off, but there's water coming out of the bottom of it, leaking and dripping and so forth. And so I looked at that and I went, oh, geez, looks like the shower head is leaking. I guess I'll have to replace the handheld sprayer, okay? Because that's the apparent cause. There's water coming out when it shouldn't be. It's coming out of that handheld sprayer, so therefore the handheld sprayer is my cause. And so to address it, my corrective action is to replace that. Okay. The problem is that's actually completely incorrect. Again, I've talked in the past about process thinking, systems thinking, that kind of stuff. If we look a little more, well, if we kind of take a step back, okay, this spray head is part of a shower system. It's got a shower head. It's got the hose connecting the handheld sprayer, and then the handle to turn the water on and off. Okay, and when you take it as a whole, then you go, well, wait a minute, is it really the handheld unit that is the root cause, or is it this valve, this selector switch, right, that you see up above there, which establishes whether the water goes to the head, the overhead shower head, to the handheld sprayer, or to both at the same time. And when I looked at it, I realized that's actually the source of the problem. The sprayer, the handheld sprayer is fine. It's that valve that when it's in a position where water shouldn't be going to the handheld, it still is. Okay. So replacing the handheld sprayer would not have resolved the problem. It wouldn't have worked well as a correction or as a corrective action. I needed to replace the selector valve unit. Okay. The other place, and this is a good example as well, that handheld sprayer goes for about $50. Okay. It turns out the selector valve only cost me $20. So I would have wasted resources and time and not solved the problem and would have still had to make the time and the payment to get the correct part in there. And that happens a lot when we don't think about going beyond those apparent causes. The other example I often use with my students is if you're walking through the factory one day and you see a puddle of water on the ground and you look up and there's a leak in the pipe overhead. And then I ask, what's the root cause? Is it the pipe? Okay. That would be the obvious one. That would be the apparent cause. The pipe is leaking, is creating a puddle on the floor, which creates a danger. Okay. So then what's my corrective action? Seal the pipe, if we're following along this logic. The problem is we've not asked why was the pipe leaking. Okay? It's basic five whys kind of thinking, right? We're just accepting the fact that it's leaking, and if I fix the leak, then I'm good. But we don't know why. Is Was it a bad weld? Okay, why was it a bad weld? Do we have any other bad welds somewhere in the, in the piping system? Or maybe the pressure was too high in the pipe and that's causing leaks to occur, which means patching up that one leak just means it might, blow a hole somewhere else. Okay, so you got to do that again, that five whys thinking. All right, why is there a leak? Okay, it looks like the pressure is too high in the pipe. Why is the pressure too high? Well, let's go back to the control room. Oh, looks like the pressure valve, the pressure controller has gone bad. Okay, do I replace that and move on? No, wait, why is the controller bad? Well, we don't do any maintenance on it. Why don't we do any maintenance on it? Well, we don't have a maintenance plan for it. Why don't we have a maintenance plan for it? Well, we never actually validated that part of the system. Why didn't we validate that part? You see where we're going here? We've started somewhere in the factory where we observed a nonconformance, but the root cause has nothing to do directly with what we observed and where we observed it. It is physically in a completely different place, and it's also in a completely separate part of the quality system. And that's very common when you're doing root cause analysis. Now, back to the idea of root cause versus apparent cause or just addressing cause. The reason I think it's important to focus on root cause is because you're looking at a sequence of events is what you've built up here. And ultimately what you want to do is you want to eliminate the trigger, the place where it started. Because if I do that, then none of it can happen again. If you just take this approach of it's a cause, then the symptom is a cause, right? That pipe would be a cause, and I could just fix patch it up, and you'd think you're good, but that doesn't mean it isn't going to recur. And the same thing, if you don't go far enough back in the sequence of events, it may temporarily create a solution, but ultimately it's not systemic thinking and it may pop up somewhere else or it may just occur in the same place again. So really you want to get to the root cause because that root cause says this now creates a situation where none of the other steps in the sequence are now possible. And if we apply that elsewhere, what other controllers, what other water pressure controllers do we have that might be going through the same thing? What other types of controllers in general? Is this the only factory we have with that kind of setup? Right? You start to broaden your thinking, take a wider view of the scope, and go, now our corrective action can be applied more broadly, and therefore its impact is more broad. Whereas if you just focus on the apparent cause or any of the causes along the way without getting to really to the truly to the root cause, you are likely to still have problems somewhere else in the system. And that's why you really need to change your thinking on this. So I'm very curious to see what kind of comments will come up. I expect that Mark will have something to say. So that'll always be entertaining to see us go back and forth on this. But please, let's see your comments and let's get a good discussion going. Otherwise, I'll see you next week on the Quality Heretic.